Alright, welcome to my YouTube channel. I am Precious Uboise. So we'll quickly look at angles between two vectors. Previously, we looked at dot product of vectors, and we established that if you have two vectors, say vector u and v, that the dot product of u and v is equal to the magnitude of u multiplied by the magnitude of v times cos theta, where theta is the angle between the two vectors. Okay, so from this relationship, it implies that cos of theta is equal to u dot v all over magnitude of u times the magnitude of v. Okay, and so with this formula, we will be able to find the angle between any two vectors you are given. So just find their dot product, the two magnitudes, and then substitute into this formula, and then you find the cos inverse of your value on the right hand side, and that will give you the value for the theta. Okay, so this relationship is important in the study of vectors, and we are going to see some of its applications. So the first thing to quickly remark before we go into examples is that number one, if you have two vectors u and v, if your u and v are parallel, if they are parallel vectors, remember we talked about parallel vectors, that's vectors that we call collinear vectors. If they are collinear vectors, then it implies that u dot v is simply going to be equal to the magnitude of u times the magnitude of v. The reason is because if they are collinear vectors, then your angle theta is going to be 0, because the angle between two parallel lines is 0. Of course, they will never meet at any point. And so because it is 0, and we know that the cos of 0 is 1, so when you put that into this, that's going to give us this relationship. And then secondly, the second thing we are going to note here is that assuming the u and v are not parallel, but they are perpendicular. If u and v are perpendicular vectors, so what it means is that angle theta is 90 degrees. And so if angle theta is 90 degrees, and we know that cos of 90 is equal to 0, so that implies that the dot product of u and v in that case will always give us what? 0. So whenever you have that the angle between two vectors is 0, then the dot product of those two vectors will definitely be 0. And then if you go on the other side, it means that if you get the dot product of two vectors to be 0, then those two vectors are perpendicular. Okay, so we'll quickly look at some examples now. Okay, so examples here says that find the angle between the following pairs of vectors. Okay, and so we are given two pairs of vectors, A and B. All right, so we will do the first one. Okay, so to find the angle between these two vectors, we will remark that cos theta is equal to u dot v all over magnitude of u by magnitude of v. Okay, so from here we can try to find all the things we need here, and so let's do that. Our u dot v is going to be, remember it is a component form, so we'll multiply the corresponding component, which is going to be 5 times 1 plus 4 times minus 3, and that's going to give us 5 minus 12, which is minus 7. That's for u dot v. And then what about the magnitude of u? The magnitude of u is going to be the square root of 1 squared plus 4 squared, which is equal to the square root of 17. And then magnitude of v is equal to the square root of 5 squared plus minus 3 squared, which is equal to the square root of 25 plus 9. and that is 34. Okay, so having gotten that, it then means that our cos theta is equal to minus 7 all over the root of 17 times the root of 34, which is minus 7 all over the root of 17 multiplying 34. Okay, 17 times 34 is 578. Okay, so, and let me try to finish that here. And that means our cos theta is equal to approximately, and the cos inverse is going to be the value of our theta. Okay, so simply find the cos inverse of this value, and that will be the value of the angle that we are looking for. Okay, and then if you apply the same thing for B, you should be able to get the value of B. Find the dot product of A and B, and then find the magnitude of the two and try to solve for the angle theta. Now let's quickly look at this example here. Very nice example that we want to consider. And then the example says that we are given the vector u here. We are asked to show that any scalar multiple of u is indeed parallel to u. Meanwhile, our u is the vector 0, 2, 1. Okay, then when we talked about scalar multiples, we said that scalar multiples is just to multiply a particular vector by a scalar, by a number. Okay, so, and if you multiply, for example, let's assume that this is a vector u. If you multiply this u by 2, it will simply give you another vector that will be in the same direction. In fact, it will be parallel to u, but the only thing is now it will now be 2u. That's double of this. Okay, so to show that is actually true, that's what they're asking us to do in this example. So all we need to do is to find any arbitrary, like they said there, that we should find any arbitrary component, any arbitrary scalar multiple of this. Okay, so we can simply just use 2u or whatever. Okay, so now this means that 2u is going, which is a scalar multiple, is going to be 0, 4, 2. And so to show that it is parallel, all we need to do is to take the dot product, and by what we said earlier, if the dot product gives us exactly the same thing as the the product of their magnitude, then we say that they are parallel. Okay, so let's find the dot product of u and 2u. The dot product is going to give us, and then if we take this, we are going to get 0 plus 8 plus 2, which is equal to 10. All right, now so let's find the magnitude of u multiplying the magnitude of 2u, sorry. And now what is our u? The magnitude of u will be the square root of 0 plus the square root, the square of 0, square of 2, square of 1, which the square root of 0 squared plus 4 squared plus 2 squared. And this, of course, going to give you the square root of 5 times the square root of this is 16 plus 9. 16 plus 9 is 20. Sorry, 16 plus 4 is 20. And that's going to give us the square root of 100. And that is equal to 10, which is exactly what we have here. And so since the dot product of the two vectors is equal to the product of the magnitude of the two, then we say that both of them are what? Parallel. And we can actually do this using an arbitrary approach. An arbitrary approach is to multiply u with k, so that you are going to have 0, and then you will have 2k, and then you will have 1. Okay, try to find the magnitude of this. The magnitude of this ku is going to be equal to the square root of 0 squared plus 4k squared and then plus k squared. Okay, and that's going to give you the square root of this is going to be 5k squared, which is equal to root of 5k. And then whereas the magnitude of u, we have gotten it to be equal to, in the earlier place where we took the magnitude of u, we got root of 5. And so if you now multiply the magnitude of u by the magnitude of v, you discover that that will give you the root of 5 multiplying root 5k, and this is going to give you 5k. Okay, this is our 5k now. That's the product here. So we need to take the dot product of u and the ku that we took here, and this dot product is going to be 0 2 1 dot. And if you take this, you are going to have this by this is 0 plus this by this is 4k, this by this is k, and if you add up this, you will have 5k. So even when you do it with an arbitrary constant, now here we just used 2, but even when you do it with an arbitrary constant, you will definitely get that the product of the magnitude of the two vectors will always be equal to the dot product if they are scalar multiples of each other, and that is what we are required to show. And that's where we'll end it for this video. Kindly subscribe to our YouTube channel, and we'll see you in our next video. Bye.